Our first example will be about a continuous beam, and it will be divided into 2 videos. In the first video, we will create the geometry, members, cross-section and material, and assign supports. In the second video, we will create static analysis settings, load cases, design situations, and load combinations. Afterwards, we will apply the load on the members. In order to follow our online course, you need to install the Dlubal plugin for Rhino and Grasshopper. You can find it in the Dlubal folder under Tools. Double-click on the file to run the installation. After completion of the process, start Rhino Grasshopper and RFEM. First, we will show you some information about Rhino Grasshopper. When we start Rhino, we have 4 default viewports: top, front, right, and perspective view. To rotate the perspective view, hold down the right mouse button. You can zoom in or out by scrolling. You can pan by holding down the mouse wheel. For other views, you can pan by holding down the right mouse button. To minimize or maximize a viewport, you can double-click on the Name tab. You can also change the viewport from the Viewport tab here. You can change the display mode of a viewport as well as many other settings by clicking the Name tab, as you can see. To launch Grasshopper, type Grasshopper into the Rhino command line or use the command Launch Grasshopper in the Standard tab in Rhino. The Grasshopper window will appear on the Rhino viewports. You can divide the screen into 2 parts by holding the Windows key and pressing the left or right arrow key. We will display more information and features during the course. Now, we will begin with the geometry. First, we will create a point using the Construct Point component. You can find this component in the Vector tab. Then drag and drop it from the Vector tab onto the canvas. You can also create a construct point by double-clicking the canvas and writing Construct Point. By default, the coordinates of the first point are 0, 0, 0. You can read any information in a component using the command panel, which can be found in the Params tab, as you can see. Afterwards, we will copy it twice using Ctrl+C and Ctrl+V or by holding the Alt key and dragging the component. For the second point, we will assign a number slider to the x-coordinate, so that it can be easily adjusted later with the slider. You can find it in the Params tab using drag and drop or by double-clicking the canvas and writing number slider, as you can see. For example, we will create a range by double-clicking the slider. The lower limit is 1 and the upper limit is 10. You can also enter the slider name. To do this, we enter first span, or set the rounding by selecting any type you want. For the third point, we will insert the expression component to define a parametric equation between the first and second spans. You can find this component in the Maths tab under Script. Double-click the expression component to open the expression editor and change the expression to x plus y, where x is the first span length and y is the second span length. You can create a range for y, either with a number slider command or by double-clicking the canvas and writing the lower limit, 0, then, less than, and the upper limit. We enter 10 for the upper limit. You can click the plus sign to add an input or the minus sign to remove an input. Now, we connect x and y to the expression component. In the next step, we will create lines between these points using the line component in the curve tab. We use drag and drop, or we double-click on the canvas, write line, and select the respective line. In our example, we select the line, which has a start and an end, as you can see. Afterwards, we connect the start and end points of each line to the line component. To create a member for RFEM, we insert the Dlubal component titled Member. You can find it in the Dlubal tab. Here, we can also define the member type using the value list command with drag and drop, which is also in the Params tab. We can also double-click the canvas and write value list. For this example, we select the beam type. Now, we connect the line components to the grasshopper line in the member component. By default, a new connection will erase existing connections. Hold down the Shift key while dragging the connection wires to define multiple sources. The cursor will turn green to indicate the addition behavior. You can disconnect wires by holding down Ctrl and dragging, or by right-clicking the connection and selecting Disconnect. As you can see, when we hover over an item, the wire will be highlighted in red. Next, we will define a cross-section as well as material. For that, we will insert the Dlubal components, section, and material. You can also find them in the Dlubal tab. To enter the properties of the section and material, we use the panel command. Now we enter the numbers and names. For cross-section, we enter 1 as the section number and IPE 300 as the cross-section name. For material, we enter 1 as the material number and S235 as the material name. Make sure that you use the correct RFEM terminology. Only then is it possible to export the elements correctly to RFEM. Afterwards, we connect the material component to the material number in the section component and connect the section component to the section start in the member component. In the next step, we want to define the supports. To do this, we insert the nodal support component, which is in the Dlubal tab. For the first node, we want to assign a hinge support. This can be defined by using the panel command. As you can see, 0 means free, infinity, INF means rigid, and every specific number in between means spring. Then, we connect this panel to the respective support conditions. We repeat the same procedure for the second and third supports, but with other conditions, because we want to define sliding supports. To transfer this model data to RFEM, we have to insert the Dlubal component, RFEM6 export component. We also have to activate Web Services, which is in the Options tab, in RFEM 6. Start the server automatically with the application. To start the export, we use either the button or the Boolean toggle command in the Params tab. For this example, we want to use the Boolean toggle command. We can also select units using the value list command. For this example, we select meters. In addition, we can overwrite the previous data in RFEM using the Boolean toggle command. That means all data in RFEM will be deleted before the export, once we switch to true. To make the work easier, we will make groups, for example, a group for geometry, member, and so on. We can create a group by typing Ctrl+G with the desired component selected. To edit the name and appearance of the group, we right-click anywhere on the group. Here, we can enter the name of these groups, for example, geometry, supports, etc. We can also change many options, such as outline type, add to group, remove from group, or change group color, as you can see. After connecting all the components to the RFEM 6 component, we double-click the Boolean toggle command to perform the export. All changes to the parameters in Grasshopper now have a direct impact on the RFEM model. In the next video, we will learn how to create static analysis settings, load cases, design situations, and load combinations, and apply the load on members. Thank you for watching. If you have any questions, you can write them in the comment section below. If you like this video, don't forget to like and subscribe. You can also visit our website at dlubal.com and search for anything you need.